Stoichiometry of SN1 unimolecular substitution reactions. The stoichiometry shows the substitution occur with a mixture of retention and inversion at a stereocenter. This means that attacking nucleophile can attack on the carbocation from both the sides. Either from the sides of the living nucleophile you will get a retention, or if attacked from the back side of the living nucleophile you will get inversion. Means that if it is S isomer you can get S isomer as a product or R isomer as a product. So here a retention and inversion both occurs during this reaction. Studying the rate law of this reaction, the rate of the reaction only sensitive to the concentration of the substrate and not the attacking nucleophile. Means the rate equation shows that the rate is only proportional to the concentration of the substrate, that is the tertiary alkyl halide. Why? Because if we use experimental techniques and if you increase the concentration of the substrate, the rate also increases. And if you increase the concentration of the attacking nucleophile, the rate remains the same. Doubling the concentration of water has no effect on the rate. This shows that this is unimolecular nucleophilic substitution reaction because it depends upon the concentration of the substrate only. The substrate may be tertiary alkyl halide, secondary alkyl halide, or primary alkyl halide. So this experimental data shows that this SN1 is most favored by tertiary alkyl halide, and if you look at the rate, it's a very high rate. But for the primary alkyl halide, the rate is very slow. It shows that SN1 mechanism is favored by tertiary alkyl halide more than secondary alkyl halide, secondary alkyl halide more than primary alkyl halide, and in the last you can add methyl bromide or any methyl alkyl halide. In mechanism, it is a two-step mechanism. The first step is very slow and the second step is fast. This is the first step in which the living nucleophile bromide leaves the planar carbocation. Now, the OH that is an attacking nucleophile, it has two chances to attack on the planar carbocation. If it attacks from the right side, you will get the final product as S isomer, and it can attack from the left side and we will get the product as R isomer. Both after deprotonation you will get it R isomer here or S isomer or both. So in this mechanism, retention and inversion both occurs and you will get a racemic mixture. These two are the second step. They are fast step, while that was the first step, that is the slow step, the rate determining step.